In this video, we're going to walk you through promoting your first Lambda expression from the REPL to your spreadsheet using our Lambda function. This will allow you to persist it on closing and restarting Excel. As you may recall from our previous video, we often work in the REPL when testing out our ideas. In this case, we have the canonical recursive factorial definition, and we're going to execute that by doing Control-Shift-T. It's now available for us to call, and we can do that in the REPL by simply referring to it by its name and trying it out with a few values. And the advantage of doing this in the REPL is that you can see immediately the result and be sure that it's working, right? So now the task is to make this reusable in a way that will persist in the spreadsheet. And toward that end, we have a Lambda function. Actually, we've got 4 related functions, but we're going to start with the Lambda function, which is actually the Greek letter lambda. We're going to make sure we're focused on B1 here. We're going to go ahead and click that. So what just happened was it inserted a valid Lambda statement, and this is just sort of boilerplate to get you rolling. And the idea here is that what you're going to do now is you're going to grab the actual Lambda code out of your definition in the REPL, and what we're going to do is copy and paste that for the boilerplate. Okay, now we have an issue in the case of recursive functions. Just in case you don't know what we mean by recursive, it means that the function calls itself in the process of evaluating to a result. And this can result in multiple calls to the function itself. In Scheme is special in that it will do that in a very efficient way. The problem is a lambda is technically an unnamed function, so we can't refer to that and expect it to work. So in the Lambda editor, you're going to use the special form called recur. Oops, I had all caps there. And that will effectively substitute the invisible name of the lambda in that place so that it can work. We'll test this with one of the values we know works. Let's use 5 for now. Oops, I didn't say 5. And you can see it's basically building this expression, which we can now accept. And there's the answer, right? We're hard coding 5. So let's get rid of the REPL here to make some room. So what we can do now is we can click on this like we would ordinarily, and in place of this hard-coded value, we can actually type A1. And you'll see, just like you would normally expect in an Excel function, it's pointing to the first value in row A. So we accept that by hitting Enter. And of course, the factorial of 1 is 1. But what we're really interested in doing is copying this. And we're going to paste it, but first let's make some room. Okay, and we're going to hit Enter, and there it goes. You can see that the numbers get pretty big, and we can make it format this as a number. Let's see, go to it's a number, and we can make it a little wider. And there you have it. So we've created this Lambda function. And we've copied it in each of these places, and just as we expect with normal Excel values, it shifted and always gets the correct one, and that's exactly the behavior that we want. We also talked about how we use this recur form in order to substitute for what would otherwise be the name of the function that we're creating. In our next video, we'll cover promoting your new function from an anonymous Lambda expression to a function with a proper name using our define function. It acts just like the define form in the Scheme REPL, except it allows it to persist and ensures that it compiles at most once, no matter how many times you reuse it. We've now covered the first step of evolving your random REPL experiments into real code you can reuse, and you have met the Lambda editor. You'll get to know the Lambda editor better in our next couple of videos as we show you how to create a named Lambda expression and use it with apply and eval. Until then, thank you for watching, and if you have any questions, please don't hesitate to contact us.